Hello viewers, so my friend requested me to do a video covering bearings. So that's what this video is going to be about, bearings. So to give you some context on why we use bearings to navigate around or find other objects, we first have to take a look at this fella over here. So I'm just gonna draw this guy. This guy is John, alright? And beside John, we have another person called Sally. Okay? So if I'm gonna ask John, where is he from Sally? He's just probably going to say, oh, I'm probably like left from Sally, and she's probably like right from me. Yeah, that's something he's probably going to say. So yeah, if you go around telling people that, sounds really stupid, and it will cause a bit of confusion because our left and rights differ depending on how you perspective. So yeah, we use bearings to determine our location to others. So I'm just going to erase this real quick. So I want you to take a look at your cardinal directions. You know what your cardinal directions are, right? Your northeast, southwest. Yeah, those. So just going to draw this out. So these are your cardinal directions. At the center here, I'm going to call this the origin, okay? So, bearings are basically a measure of angle from the north at the origin, and it will go in a clockwise direction and the angle has to be denoted as a 3-digit number. If you're confused, hold on. So, same example as just now. I'm going to pretend that I'm just going to say that John is now standing at the origin, and Sally is like somewhere in the northeast of John. So if now I ask Sally where is John, she's just probably going to say, she's over there. I don't know. Okay, yeah, so we're going to use bearings to find where are they from each other. So applying this measure of angle from N at O, that means that our angle will be surrounding O, and we have to start from N, so therefore we have to move here. So in what direction? Clockwise. So we move from N to Sally in a clockwise direction, and then now we can connect a line here. This is the distance from each other. Okay. And the angle created will be this angle over here, from north to the line from John to Sally. Okay, I'm just going to call this angle here theta. Okay. So, yeah, that will be the bearing of Sally from John. So let's say that theta equals to 30 degrees, okay? So how do I write this as a bearing? So like I said, bearings have to be denoted as a 3-digit number. But how do you turn 30 into a 3-digit number? Easy. So the bearing of Sally from John will equal to 0, 3, 0. Basically, for 2-digit numbers, you just add a 0 in front of it. For 1-digit numbers, you add 2 zeros in front of it. Okay? So, now we found the bearing of Sally from John. Let's find the bearing of John from Sally. So then again, I'm just going to draw my cardinal directions, but this time from Sally. Alright? So now we have that. Let me erase this. This is my origin, my other origin now. So like I said, we have to start from N at O in a clockwise direction. So therefore, I'm going to go like this all the way until the line where they are connected. So this reflex angle, well, let me use another color. Let's use purple. This reflex angle over here will be the bearing of John from Sally. Okay? So how in the world are we going to find that angle? Well, we can use this theta, the value of theta, to help us find it. Now, as you can see, these north this line over here, they're parallel to each other because they're all facing north. So therefore, we can use our angle rules. And since we know that theta equals to 30, therefore this angle over here is another color. Change it. Okay. This angle over here will be equal to 180 minus 30, which will give you 150 degrees. And as you can see, this whole round here is 360 degrees. So to find this reflex angle, all I have to do is to take 360 degrees minus 150 degrees. Alright, and all I'll get is 210 degrees. So the reflex angle, or the bearing of John from Sally, will therefore equal to 210 degrees. So that's how bearings work. Yeah. So it supposedly makes things easier to navigate around and find each other. Okay, so let's just do one quick example really quick. I'm gonna draw my cardinal directions again. This will be east, this will be south, and this will be west. Alright. From the origin, A, B, C, somewhere around there. Alright. No, wait, I want to do C here. Okay, so what if I want to find the bearing of A from O? Basically, same thing again, clockwise direction to A. And this angle here is just conveniently a 90-degree angle. So therefore, bearing of A from O will equal to 090 degrees. Okay. Okay, now how do I find B? Now let's say, for example, they gave me the angle over here. From this line to B, the angle from B to the south is let's do 36.9. Yeah. So how are we supposed to find the bearing of B from O? Very easy. We know the bearing of we know that N to E will be 90 degrees, but now we just need to find this angle over here. So all I have to do now is to take 90 degrees minus 36.9 degrees. Why? Because this angle here is 90 degrees. And that'll give me 53.1 degrees. Okay? And then now all I have to do is to add the 90 degrees up here with the 53.1 degrees. So 90 plus 53.1 will give me 143.1 degrees. Now how do we write this as a bearing? Well, easy. For decimals, you don't really have to care. It's just the whole numbers at the front. So the bearing will equal to 143. We have our 3-digit numbers. And just add our decimal at the back. Doesn't matter. There you go. That is the bearing of B from O. Okay. Now, let's do something a little bit more different. I want to find the bearing of O from C. So very easy. Draw our cardinal directions at C. Same thing again. And since all the north lines are parallel and this one's parallel as well, so we can denote that this is perpendicular, so 90 degrees here. So the bearing and the line connecting C to O is just nice, lying on the line of the east to the west. So therefore, the bearing of O from C will equal to 090. And there you have it. That's bearings for you. So, thanks for watching. Hope this helps.